Hello everyone, my name is Lingpei Shi. My thesis topic is the design and manufacture of FSAE carbon fiber suspension arm, supervised by Dr. Andrew Lozzi. Unsprung weight is a mass of a vehicle's suspension and other connected components, not supported by the damping of the suspension. Light unsprung weight setup enables the suspension to react the bump more quickly and providing less wheel movement, which can improve the performance of car. So by replacing the materials of control arms with carbon fiber enables the FAC car to have better mechanical grip, which is the aim of my thesis. It is crucial to find out the maximum compression and tension loads on each control arm. A schematic diagram of real suspension was drawn to analyze the force based on the 2020 car's suspension geometry. Since we are assuming a static situation while analyzing, we can set up three formulae based on equilibrium for force and moment about x and y-axis. The only parts of these two moment equations are the moment based on x and y-axis from force 1 to force 6. A matrix system can be set up based on previous three equations, and the results were solved by MATLAB. The calculated load results for all front and rear control arms are shown here. Some data is not available because there's only one direction of loads exerting on that control arm. A maximum load of 3000 Newton will be used for FEA analysis. Aluminium 2024-T4 has been chosen to make mounts and inserts. 2x2 12-woven pattern carbon fiber tubes with inner diameter of 16 and outer diameter of 18 mm have been chosen to make control arms. Plexus MA300 and PC120 have been chosen for adhesive and pretreatment materials. The female insert was designed for holding tubes. It has larger contact area comparing with male inserts because it contacts to the outer layer of tubes. There will be a 0.2 mm bond gap for adhesive to place. Two holes will be drilled to fill adhesive into the bond gap. Adhesive will be injected from point 1. It will fill the bond gap till adhesive come out at point 2. All the mounts have the same bond gap and bond length design as inserts. The dimensions and angles are based on suspension geometry on 2020 car. A rear lower suspension assembly connecting rear lower control arms and push rod have been shown here. Same as all mounts and inserts. The bearing house of mounts will be placed at 5/16 spherical bearing, and the rod and inserts will have 1/4 spherical bearing. A rear upper suspension assembly for connecting rear upper control arms and toe link had been shown here. In this FEA analysis, aluminium 2024-T4 had been applied as material. 6,000 compression and tension loads had been exerted on thread part, and the fixed geometry will be bonding area. We can see it has a factor of safety of 3.76 and 3.4 relative to compression and tension situation. Since inserts have the most number of quantities and directly connect to the tubes, during this analysis, the 1 mm thickness cross-section area highlighted with blue on tube will contact to the base of inserts. A 6,000 compression force will be applied on this area, resulting in a factor of safety of 4.13. Here, the FEA analysis for front lower mount will be shown as an example of all control arm mount. It was performed by fixed geometry at bonding area, and 6 kN of vertical load applied on both push-rod bracket. A factor of safety of 3.46 had been achieved. The analysis for toe mount was performed by applying 6 kN and 2 kN of load on bearing holes and holding connection, respectively, which is 2 times larger than the theoretical maximum load. Rarely will happen in the real situation, and it achieved a factor of safety of 1.56. In conclusion, all the components plus the tubes have the mass of 2,635.24 grams. This design achieved a 40.81% of unsprung weight reduction. Thank you for watching.